Hello class. In this video, we're going to start our lessons on fraction division, but we're only going to focus on the whole numbers divided by a fraction. But before we start with this lesson, I want you to pause the video, write your proper heading in your notebook, including your first and last name, the date, mathematics, and your period number. And don't forget to title it Fraction Division dash Whole Numbers Divided by a Fraction. Now that we have our heading in our book, we can discuss about fraction division. Fraction division is a big section that we're going to break up into shorter pieces so that we can focus on all parts. So in this lesson, we're going to focus on taking a whole number and divide it by a fraction. So when we're doing this, there are a set of rules that we need to cover. So here are our rules on how to divide fractions, and this applies to all fractions, even the other videos that will come after on fraction division. So rule 1 is we need to change all mixed numbers into an improper fraction. We also need to take, at this point, any whole numbers and make that as an improper fraction as well. Then the second step while dividing fractions is we need to use what we call KCF, which it means keep, change, flip. We're going to keep the first fraction, change the division to multiplication, and flip or find the reciprocal of the second fraction. I know it's a little confusing here, but we're going to put that into effect in our next examples. Okay, then the third step is to multiply straight across. Now we've done this before when we were multiplying fractions, numerator times numerator, and then denominator times denominator. And then our last step is to simplify. Okay, that's making sure that if our answer is as an improper fraction, we make it a mixed number, or if we can simplify taking a number to divide the numerator or denominator. So these are our 4 steps. Before we go on to the example though, I would like you to pause this video and write down our title here and the 4 steps so that it's easy for you to refer back to your notebooks. Now that we have the steps, let's try to put this into an actual process, because I know right now you're probably getting confused with this KCF because you may not have seen it before. The rest of the stuff I'm pretty confident that you have no issues with, but the KCF I believe it is. So let's actually look at some examples. So here we have our first example, 7 divided by 3/4. And I'm going to use different colors for the steps so that you can see where it comes from. Now, step 1 said to change all mixed numbers into improper fractions are also making whole numbers that are not attached to a fraction as an improper fraction. So here we have the number 7. 7 is a whole number, and we need to make that in a fraction. Being that we don't have a fraction attached to it, making it a mixed number, some people are like, how can we turn around and make this into a whole improper fraction? And the simple thing is we put it over 1. So the 7 becomes 7 over 1. And then I just copy the rest of the problem. Before I move on to the next step, I need to turn around and look at, do I have all of my digits now as an improper fraction or a proper fraction and not have any whole numbers? In this case, I do. So now I need to go to the second step. The second step is KCF. And I like to write those initials underneath each of the terms so that it's easy for me to know what I'm doing. So here, the K goes to the first one, and that means K means to keep. So I'm going to keep that as 7 over 1. The C then goes to the second step, which is the division, and we're going to change that. And you always change that to the inverse. And the inverse for division is multiplication. So that division now becomes multiplication. And the last one is the F, and that goes to the last term. And that means to flip or find the reciprocal. I'd really like you to use the word reciprocal because that's what you'll be using in 6th grade. And that just means you're flipping them. You're turning them upside down. So what's in your denominator is now your numerator, and what's in your numerator is then your denominator. So 3/4 then becomes 4 over 3. And that's our second step. So I know that we're a little confused there, but it's just you keep the first ones the same, you change the division to multiplication, and you flip the last term. Now you go into your step 3, and your step 3 is to multiply. You multiply straight across. So you have 7 times 4 in your numerator and 1 times 3 in your denominator. 7 times 4 is 28. And 1 times 3 is 3. So that is our third step. And last but not least, we need to simplify. Since I automatically see that my numerator is larger than my denominator, I know I have whole numbers in there. So what I'm going to do is I'm going to divide. How many times does 3 go into 28? And I know that's 9, because 9 times 3 gives me 27. So I'm going to make my whole number 9. And like I said, 3 times 9 is 27. So I took 27 pieces out of here. And I'm left with only one more. So that's my numerator. And then my denominator stays the same. Since this can't be simplified anymore, I know that that's my final answer. So I'm going to circle it. I want you to pause this video now and write down this example in your notebooks. Now that we have that, let's look at another example. Here we have 8 divided by 2 over 12, or 2/12. Our step 1 says that we're changing all mixed numbers into improper fractions, or you're also changing any whole numbers to an improper fraction. And remember in the last example, we said we could take a whole number that is not attached to any fraction and just put it over 1. So the 8 becomes 8 over 1, or 8 ones. I then recopy everything else down. The 2/12 is already an improper fraction with no whole number, so I could just recopy it. Before moving on, I'm going to re-verify to make sure that I have no whole numbers. I have none right here that's written down, so I'm going to move on. So now I got to do the KCF. Again, that means the K goes to the first term, in this case, 8 over 1, and I'm going to keep that the same. So I'm going to rewrite that 8 over 1. The second one, the C, means I'm going to change my operation. So I'm changing it to the inverse, and the inverse of division is multiplication. And then last but not least, I'm going to use the F. I'm going to flip. Again, I want to use the word reciprocal because that's what you'll be using next year. So the reciprocal of 2/12, I just flip it around. Remember, the denominator is now my numerator, and my numerator is now my denominator. After I do the KCF, I could then do the multiplication. That's the third step. So I'm doing 8 times 12 as my numerators, and 1 times 2 as my denominator. When I do this, 8 times 12, that's a bigger number. So I got to do 8 times 2 is 16. And bring down the 6, I carry the 1. 8 times 1 is 8, plus that 1 I carried over gave me a 9. So my numerator is 96. And 1 times 2 is 2. Now that I've multiplied, I can go into the last step of simplification. Again, here I notice that 96, my numerator, is larger than my denominator. So then I would just divide it. 2 goes into 9 4 times, because 2 times 4 is 8. I have 1 left over, and then I bring down the 6, so it's 16. 2 goes into 16 8 times. So 48 times 2 is 96, so I'm left with no remainder. So I have nothing in my numerator, and my denominator stays the same. And when I have this, I can always drop the fraction when my numerator is 0. So this really does equal 48. And then I'm going to circle it as my final answer. I want you to pause this video now and write all of your notes in the notebooks. Now that we have this, let's do one more example. Okay, so I have 10 divided by 9/11. Step 1, I'm making this 10 be 10 over 1, and then I copy everything else down. I have no more whole numbers as written as a whole number, so I can continue on to my next step, which is K, C, F. So if K stands for keep, so I'm going to keep the 10 over 1 as 10 over 1. The C stands for change, so the division now becomes a multiplication. And then I'm going to flip the last term. So 9 over 11 becomes 11 over 9, because the denominator becomes your numerator and your numerator becomes your denominator. Now after I do the KCF, I just multiply straight across, so I'm in step 3. So my numerators are 10 and 11, so I'm going to multiply 10 times 11. My denominators are 1 and 9, so I'm going to multiply 1 times 9. All right, so 10 times 11 is 110, and 1 times 9 is 9. After I multiply, I can move into my next step, which is to simplify. I notice my numerator is larger than my denominator, so I personally like to pull out my whole numbers. And after I multiply, I realize that 9 times 12 gives me 108. So I know that there's 12 whole numbers, and 12 times 9 is 108. So I pulled 108 pieces out of here, so I'm left with 2. So I have 2 as my numerator, and then 9 stays as my denominator. But just to do a side note, I'm going to actually do that division here so people can see that process. All right. So 9 is my divisor that goes outside. My 110 is my dividend. 9 doesn't go into 1, so I put a 0. 0 times 9 is 0. 1 minus 0 is 1. I then bring down the 1. 9 goes into 11 one time. 1 times 9 is 9. 11 minus 9 is 2. I then bring down the 0. 9 goes into 20 2 times. 2 times 9 is 18. And 2 minus 18 gives me 2. So you can see here, this is how I got the whole number 12. This is where I got my new numerator. And of course, the denominator stays the same. So I know that that's my final answer. So I'm going to circle it to mark it as my final answer. I want you to now pause this video and write this work down in your notebooks. Now that you have this in your notebooks and we've gone over a couple examples, I want you to try some on your own. I want you to do 8 divided by 2/5. So that's saying 8 divided by 2 over 5. And then I want you to do 4 divided by 3 over 7. So I rewrote it the way that you normally are used to writing it. I want you to show all of your work in your notebooks with your final answers. Remember, you can rewatch this video at any time and refer back to your notes at any time. Don't forget to send me messages if you are confused with anything.